Okay, so this is for question 11 on that paper 2 that you've just handed in, and that was a differentiation by first principles question. There are three things we need from the formula sheet for this question. One is the formula for differentiation from first principles, which I'm not sure you need, but it's on there. The other is the cos A plus B formula, which you definitely will need. And then the small angle approximations formula, which you definitely will need. So let's use those three. Before we come to the question itself, I'm just going to remind you about differentiation from first principles. Sorry about the light, by the way. It's evening, and this camera doesn't cope very well. Anyway, let's go back to working out what you get when you differentiate something like 3x squared from first principles. I mean, we know what the answer is. We know that dy by dx, or f dash of x, is going to be 6x. So, we already know that. But let's see how we can prove that. So Leibniz, Newton, both did something very similar. They said, right, if I want to work out the gradient of this curve, which is varying, so let's say I want to work out the gradient at this point, well, I can sort of approximate it by taking a point a bit further along. Let's call that h further along. So you've got x is x and x is x plus h, and drawing in a chord. And we can work out the gradient of that chord by saying, well, this distance is h. I've gone from x to x plus h. And this distance, well, this is the y value when x is x, which according to that rule is 3x squared. And this is the y value when x is equal to x plus h. So that's 3 lots of x plus h squared. So this distance here is 3x plus h squared minus 3x squared. And so what that means is we can then bishop it. So we could say, right, so the gradient is this distance divided by this distance. That. And that's what that formula is telling us. It's saying that the gradient, formula for the gradient, f dash of x, is equal to, hang on a minute, let's shift everything up a little bit, there we go, is equal to the y value when x is x plus h, so in this case it was 3x plus h squared, minus the y value when x is x, 3x squared, divided by h. That's what that formula is. And then the genius thing is that this chord is a better approximation as h gets smaller. So as you move this point closer and closer and closer and closer to the original point, you get closer and closer and closer to the actual gradient. So what we say is, right, we want to work out what this is. Let's find the limit of this as h tends to 0. So I've been a bit lazy. I've gridded x plus h squared out and multiplied it by 3. That gave me that. And then I need to take away 3x squared and divide it by h. I said, right, 3x squared, take away 3x squared, no x squared, so I'm left with that. And then I can divide all three terms by h. We know h isn't 0, because we can see it's a small value, but it's not 0, so I'm okay doing that, which gives me that. And then we say, okay, what happens as h gets very, 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 very small? Well, this term will get very, very, very small. In fact, eventually it'll disappear. So we're just left with 6x. And that, if you remember, is what dy by dx is for 3x squared. So that's what differentiation by first principles does. Okay, so let's have a look at differentiation by first principles when the formula is y equals cos x. So let's just use now the formula from the formula sheet. So when y, or f of theta, is cos theta, the formula, differentiation by first principles, says that it's f of x plus h, or in this case cos of theta plus h, minus f of x, just cos of theta, over h. Now, this is where the cos a plus b formula comes in. So if I make a equal to theta and b equal to h, I can expand that. So you might want to pause at this point and do that. I'm just going to focus again, excuse me. I'm now going to show you that, so if you want to have a go at that yourself, pause. There we go, so you get cos A cos B minus sin A sin B. Now we're then saying, right, we want the limit of this as h tends to 0. So as h becomes very small, and in this case we're dealing with angles, so we're saying as h becomes a very, very, very small angle. So that's where the small angle approximations come in. Now with sine h, that's really, really easy. Sine theta is theta when theta is very, very small. So sine h is just going to become h. The cos is a bit more complicated, but what I'm going to do first is I'm going to put these two cos terms together. I hope you're happy with what I've done there. So I've got cos theta cos h, which is that term, and cos theta times minus 1, which is that term. So I'm going to replace this with just h, and I'm going to replace this with the rather more complicated 1 minus h squared, in this case, over 2. Sorry, move up a little bit, there we go. Now of course here I've got 1 take away 1, so that's quite nice, that's just going to be minus h squared over 2 times cos theta. I've just realised I've lost my minus, there we go. And that becomes that. Remember, sine h, when h is really, really small, just becomes h. Okay, I can divide everything by h. So that disappears, that becomes h to the power of 1. And what happens as h gets really, 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 really small? Well, something almost 0 times cos theta is just going to be 0. So I'm just left with minus sine theta. And that's, I know that's what you get when you, remember the original question was differentiate cos theta by first principles. Well, I know that when you differentiate cos theta, f dash of theta is minus sine theta. The question actually asks for you to show that f dash of pi over 3 is minus root 3 over 2. Well, if you, on your calculator, do sine of pi over 3, you get root 3 over 2, so minus sine of pi over 3 is minus root 3 over 2. I hope that's clear. It's a bit fiddly, isn't it? It's certainly the fiddly bit is the small angle approximation bit. So I guess there's two steps that perhaps you may have missed. One is combining the two cos terms into the factorised version there, and then replacing sine h with h, and replacing cos h with 1 minus h squared over 2. Anyway, see if that helps. If it doesn't, then come back and ask me, and we can go through it again. Take care.